Okay, so somebody's putting $4,500 in this annuity annually for 10 years. So they're taking $4,500 one year, putting it away, collecting some interest. $4,500 another year, putting it away, collecting some interest. Okay, and they do that for 10 years. So obviously the first 4,500 is going to collect a lot more interest than the last 4,500 because it's been sitting there longer, right? So we need a formula to calculate how much money we have. And Newton writes the formula in this way, okay, for P sub n, where n is 10 in this case, the number of years. If you search future value of an annuity formula online, you'll see something similar. Sometimes they rewrite this just as I, which is the amount of interest per period. But it should be the same type of thing. Okay, so what we can do is we can find out how much money they're going to have at the end of their 10 years after repeatedly depositing 4,500. And then we can calculate how much interest by subtracting it by 45,000 because that's the total amount they're contributing. Okay, but let's just do that first step. We'll find out how much money they're going to have. The deposit is 4,500. R is 0.04 and K is 1 in this case because it's compounded annually. So K is the number of times we compound. And then I'm using the caret symbol to represent an exponent here. N is 10, we said, because that's they're doing this a total of 10 times. K is 1. And then we subtract it by 1. So there's the numerator of the fraction. And the denominator is just R divided by K. So 0.04 divided by 1. Okay, so we can plug this in our account here. This parentheses is 0.04 divided by 1 is 0.04. So we got 1.04 inside this parentheses. 10 times 1 is just 10. And then 0.04 divided by 1 is 0.04. So it's getting simpler. So we've taken care of the parentheses. Exponents are supposed to come next. So I'm going to do 0.04 to the 10th power right now. By 1.04 to the 10th power. I said that incorrectly. And I'll carry out a bunch of decimals to make sure I don't get it marked wrong. We'll round at the end. So I just figured out that this 1.04 to the 10th power is this. Okay, and then I can subtract that by 1. That makes 0.4802. Then we can multiply that to the numerator. So 4,500 times 0.48024428. That's what our numerator is now, and you might be able to do this the last step without having to write it out. But this is our numerator, and then we just need to divide that by 0.04 to get our answer. $54,027.48 is how much money they have in this account after the 10 years. Okay, so to calculate how much interest, we want to subtract this by 4,500 times 10 because they put in $4,500 every year for 10 years. So this part right here represents how much money they put in. And if we subtract that by how much money they're going to have, the difference between those two is the interest. Okay. So subtract those two. So it's $9,027.48. Okay, so that's how much interest they've earned. Whoops, sorry, they said what percentage of the total balance is interest earned? Okay, so the total balance was $54,027.48. The interest earned was this right here. So to calculate a percentage, all we have to do is take the amount we're interested in, the interest earned, and divide it by the base of the percentage, which is, they said, the total balance, which is $54,027.48 in this account. And then you just multiply by 100 to finish converting it to a percentage. Okay, so we get this, divide by $54,027.48 and times 100. I get 16.7%. All right, one last edit, 16.71% to the nearest hundredth. They said 2 decimal places. So it should be 16.71 because that 9 causes us to round up.